All right, guys. How's everyone doing? Awesome. So I'm going to be presenting on a little project I did with a couple friends. It required us to go to Virginia called the CRAM Challenge. So first off, who am I? My name is Lucas. I'm a fourth-year CSEC major. Play way too many video games, mainly Overwatch and League. Going through some of these pictures, I love dogs. So Zuki and Oscar are in the first picture. Harley and Ivy are in the next picture. If you're fans of Batman, Harley Quinn, Poison Ivy. I do a little soccer. Selfie, felt cute, might delete later, you know. I have 3 siblings, so that's Kayla, Phoenix, and then this one right here, this is Annabelle. And then that's my cousins, watch a little anime, and then my dad and uncle. Okay, so first off, what is CRAM? CRAM is Cyber Resiliency and Measurement Challenge. It was hosted by NAVC. They're based in Dahlgren, Virginia. I don't know if any of you know where that is, but it consisted of 3 phases. Phase 1 was the proposal. The proposal just was like, here's what we're gonna do. Here's our solution to your request. Phase 2 was actually building the project and then presenting that project to NAVC. And then phase 3, we had to implement changes into our already built application and see how those changes affected our outputs. We needed to test cyber resilience and then calculate risk. So where did it start? So it started with just an email from Camden saying, hi guys, do you want to do this? Says, looks like easy money. So our 2 responses are and super down. So looks like a project is definitely going to happen at this point. Okay. The picture's not there. Okay. All right, so assembling the team. So the team consisted of Min, Nathan, me, and Camden. Min dealt with a lot of the pre-processing, tracking the data, making sure we had all the data we needed for our application. Nathan, senior number cruncher, actually clutched up with all the math equations that he brought out. Me, I did a lot with the GUI and with the score node functions. And then Camden was the lead and also took the head on the AI aspect of our project. So our tasks, we needed to create a GUI, parse and track data, develop a scoring algorithm, and then implement AI into the scoring, and then get to Virginia, stay in Virginia, and then win money. So at a high level, our application looks at 3 inputs, and then we want to focus on this node risk score. So a node in this system is just basically a box. It runs a service. It has certain vulnerabilities, and it has specific functions that it runs. Okay. So the system input would take the node CVE score, develop a resilience score based on those CVE scores, which is then factored into the risk score. We also use the assumed APT groups that may use these certain CVEs located on the node, and we calculated a likelihood based off that, and then we also took into account what functions were running on the node, and depending on if it were a high, medium, or low function, it was weighted differently. This is so out of order. Why is it not? There we go. Okay. So this is our scale. Resiliency and risk are our 2 metrics we're kind of tracking. Resilience is based on how likely your box is going to be protected against vulnerabilities. So a resilient box is going to be scored as a 10, and a not resilient box is going to be scored as 0. Risk is kind of the inverse of that. So the higher the risk score means that it's more likely to be exploited, and the lower the risk score means it's not really likely to be exploited. So this is where we get into the math. It looks kind of daunting at first, but it's really not that bad. So this right here, this is going to be our resilience score function. It takes each CVE score and raises it to the weight. So if a node has multiple CVEs, it will take all the scores, raise those to the predefined weight, and in our case, it was 1.4. We kind of mess around a little with the weight, kind of seeing how it would affect our output, and we just found 1.4 gave us the most reliable output. And so this other variable, floor, so we believe that when you're measuring a box's resiliency, it didn't really make sense just to average the amount of like the CVE scores and then just spit that back out. So what we implemented was a floor that takes into account the highest CVE on the node and factored it into our resiliency score so we could have higher vulnerabilities be better represented on a node. So this right here, this is our risk calculation. This is our bread and butter. This is what our entire application kind of relies on. So 60% of the risk score is based on the node resilience score. 20% is based on the function criticality score. And if you guys remember how I was mentioning the high, medium, and low function criticality, so depending on how many high, medium, or low functions we're running on it, we would weigh those differently and then factor that into the risk score. And then finally, this 20% is the APT to CVE likelihood. This is where our AI actually gets implemented. So our AI, it needed to generate an APT CVE likelihood. And the way we did this is we mapped APT tactics to CVE descriptions. And this is actually not that hard because MITRE actually has a library that you can just query and get all the necessary tactics from them. And then we got CVE descriptions from just an API. Required a lot of training. We used something called BERT. It just basically made it so we could process the text and actually get some sort of output that is meaningful for us. But it took a lot of training. I think one test could take up to 2 hours. This is what, because our data set was insanely huge, so we had to cut it down for the actual production and demonstration for the people at NAVC. So
you gotta go on your phone and give me access so we can watch this.
Okay.
Do you got your phone?
It's dead, actually.
Oh, it's dead?
Shit. Okay, it's fine. So I had a quick little demonstration of it. It just showed our GUI. Pretty simple. What I kind of wanted to show is that we ran through the resilience and risk functions for each node, and then we also did it for the system as well. So we just basically reused the resilience and risk functions to calculate the entire system. So this would be every node located in the infrastructure. And then we also, the nodes were separated into groups, and each group would then do the same resilience and risk calculation, but instead of just one node, it would do all the nodes located in that sector. Sorry I couldn't get this up for you guys. I wish I could show you that. Okay, it looks like it works now.
Oh, cool.
Okay, awesome. Let's see if it goes at 2 FPS. Okay, so as you can see right here, this is just the basic GUI. We have groups and nodes. So this number metric up here, the one I'm circling with my mouse, that's the overall system resiliency and system risk score. It's probably very small for you guys, unfortunately. But up top, it says the resilience score is 0.0029, and the overall system risk is 6.10402. This makes sense, as the entire architecture is not really that resilient. It has a lot of nodes in there with known vulnerabilities that can be exploited. And the risk score, it doesn't look that bad, but when you, in the grand scheme of things, it makes sense that it's only about a 6. Okay. Let's see how long Oh, my bad. Okay, so now we go to nodes. And basically what it's doing is it's grabbing all the nodes that it knows, and it's just reading from a CSV file. That was basically Min's job, so we could actually get the necessary data we need. So, goddamn. So clicking on this first one, my gosh, I suck at this. Okay, there we go. So if we look right here, we clicked on the firewall node, and the firewall resilience, out of all of the nodes on the system, the firewall was the most vulnerable. It had the most CVEs, it had the most function criticality. So it's gonna have a very low resilience score of, I think it says 0.49273, and then the risk is at a 9.347. And you kind of just click around in this GUI, and it will show you the metrics for every node that you click on. So let's see if it shows a different one. So you click on layer 3 switch, and you see how it says no known vulnerabilities. That means that based on our data that we have, it doesn't have any CVEs that we know of. Kind of just clicking around here. And then an important thing to mention is that each of these nodes are basically put into these groups. And I kind of mentioned this a little bit, but there's 4 groups that each system is kind of listed under. You got engineering, production, test engineering, IT and cybersecurity, and company management. So what this page is basically doing is those same resilience and risk score calculations. Yeah, so just going through each of the sectors, you're kind of just looking at that resilience and risk score again. But yeah, that basically is our application. That's every part that we demonstrated to NavC. Okay. All right, next step was Virginia. So first we had to get there. We found out actually, we didn't know we were going to Virginia when signing up to for this, so it was pretty fun to receive an email and be like, yeah, you guys should plan travel and get ready to present, I believe it was the 21st and the 22nd. So right smack dab in the middle of a school week. So I offered to drive Camden, Nathan, Min, and all of us down to Virginia so we could get present our project. So upon getting there, we got there not like super late, but we had to get up the next morning pretty early. We woke up at about 5:30, just getting ready, getting everything set. We still actually hadn't turned in our assignment just yet because there was a problem with our file upload because of how big our zip file was. So yes, and the hotel we were staying at was pretty close to the competition, so we could walk. That was a fun early morning, walking to a competition. We had to cross this insane intersection. Nathan actually ended up dropping his water bottle, and he just said, leave it, leave it. But yeah, day 1 started, opening ceremony, and we actually had some time to chat with other teams. Just another team that was staying at the hotel with us. Pretty cool guys. Where did they go, Camden? Do you remember what school they went to? The people we stayed at? It was like Tennessee something. I don't remember. But dope guys. I have a post on LinkedIn. Follow them on LinkedIn, by the way. But yeah, day 1, they gave us the rundown of how the competition was going to go. We're given a room, and we're supposed to work on phase 3 while getting ready to prepare to demonstrate phase 2. So we are basically vibing in this room, not doing much, just getting ready, making sure that all the bells and whistles are there. And I think we were there from like 8 a.m. till like 3 p.m. till we finally presented. And then we still stayed after we presented, so pretty much the building closed. And it was a really fun experience that first day. So we got dinner after day one, and we went to this place, Don Eladio's. If you know, you know. So here's a couple pictures from dinner. We went, so there's Camden's sangria, Nathan's margarita, and then that's the food we got. Yeah. So day three. Day three, we had to submit phase 3, and when I say phase 3, it just was implementing changes such as like changing the operating systems that were running on the nodes, deleting a CVE, or even changing function criticality mappings and see how that would affect our score. And this is kind of where we ran into some interesting little hiccups, I guess I would say. We found that if we change something that is supposed to decrease our risk, sometimes it would actually go in the opposite direction we wanted. And so we were tinkering with that all through day one and kind of messing around with day 2. And then phase 3, the demo was only about 15 minutes. It really wasn't anything special, but the panel was more interactive. They were able to actually give us a little bit more feedback on it. So once we finished with the demo, we got about an hour before the actual award ceremony. And at this point, all of the teams have kind of like, not necessarily know where they place, but are more open to sharing their solutions. So it was kind of interesting to hear a couple other teams talk about how they implemented their solution compared to us. And shout out to Camden. He is the only one that ended up using not just like a text-based AI that was just querying. Like other teams used Llama, another team used ChatGPT. It's pretty interesting to hear about those. But yeah, the award ceremony, pretty simple. Kind of just sitting there, crossing our fingers, hoping we win some money. Unfortunately, we did not win money. Money was awarded to 3rd, 2nd, and 1st place. Out of the 11 teams, we still don't know where we place, but I want to say we were 4th place. So, yes. But yeah, here's some more pictures, actually. Yeah, we had our own little, like, RIT label on the door. It was great. That's Nathan in front of the math, and then that's all of us. All right, guys, any questions? Yeah, well.
How much money were you guys competing for?
So the prize pool was $125,000, $60,000 for the people in 1st place, $40,000 for the people in 2nd, and $25,000 for the people in 3rd. But make sure, though, if you guys have any questions about this, ping Camden over there. Just ping him constantly until he responds. Yeah. It's going on Discord, by the way. Yeah.
Are you going to try to compete again to get a payment?
So it'd be really cool to. I'm not opposed to it. I know some of my other team members are a little iffy about just getting up and leaving for 2 days and neglecting school just for a bag, you know. But yeah. Yeah, well.
Obviously, the government, their objective with this $125,000 was like you guys to solve like their solution. Do you think any of these implementations are actually going to be used?
So the thing is, I kind of was brainstorming this personally. So 3rd place, which is interesting, they actually use ChatGPT. And the way they implemented ChatGPT, I'm kind of confused on how they would do it in a way that they could protect the intellectual property of the company, if that makes sense. Okay, awesome.